Greetings, seekers of truth. In this lesson, we are going to talk about finding derivatives of inverse trig functions. In the previous lesson, we talked about derivatives of general inverse, and today we'll talk specifics of inverse trig functions. So let's just look at a quick review of inverse trig functions. So for example, I have a function machine, and we'll call it the sine of theta machine, and we pass in an angle, and what we get out of there is a ratio. Okay. So for example, the sine of pi over 6 is equal to 1/2. Pi over 6 is the angle, 1/2 is the ratio. So then the inverse function would be where we have sine of inverse x, and our machine takes in a ratio and it outputs an angle. Okay. And there are some restrictions to this. For example, over here we can also pass in sine of pi over 6, and we'll also get 1/2. In the case of sine inverse, it has a domain from -1 to +1, and it has a range from -pi over 2 to +pi over 2. So for example, the case of sine inverse, if we pass in sine inverse of 1/2, we only get pi over 6. Okay, we cannot get both of these numbers because there's a restriction on the sine inverse function. If we were to get both of these results, pi over 6 and 5 pi over 6, then that means sine inverse would not be a function. Okay, so that was a very, very brief and brisk review on inverse trig functions, and in fact I only talked about the sine function. If you're not familiar or you have a hard time remembering, I suggest you look at some of the older notes in pre-calculus. Now I'm going to move onwards with the calculus of the day, which is finding the derivative of these functions. So I have a question here that is both kind of a brain teaser, but also will lead to something new here in calculus, which is I have this expression. This is a trig expression, and we're asked to find an equivalent algebraic expression. Okay. So this is what we're going to do. We're going to start with the inside, the innermost part. So sine inverse of x is equal to theta. And what that means then is that sine of theta is equal to x. Okay. And what this means here is that there exists a right triangle that satisfies this condition. So I'll draw it right over here. There exists a right triangle with a reference angle of theta. The opposite side of it has to be x, and the hypotenuse has to be 1, okay, because this is the sine ratio, opposite over hypotenuse. And then that means then that this length down here is 1 minus x squared, square root. So now if we're looking for the cosine of the sine inverse of x, then we're really looking for the cosine of theta, because sine inverse is equal to theta. So cosine of sine inverse is the same thing as cosine of theta. And then looking at the picture that we have here, well, let's see. Cosine of theta is the adjacent over the hypotenuse, so that's just the square root of 1 minus x squared. Okay. And what this says something pretty interesting and kind of weird. It says that this expression here, cosine of sine inverse, is actually equal to this expression here. And if you're a little unsure and not clear on that, you could actually check it on a calculator, graph this, and I bet you you will get the exact same result. Okay, So, you may think at this point, what does this have to do with anything? Well, let's look at the next question where we actually look for the derivative of the sine inverse function. So here we look for the derivative of the sine inverse. And we don't know what this is, so we are going to actually make up an equation. So we're going to start with a known equation. And we're going to start with this one. We're going to say that the cosine of the sine inverse of x is equal to the square root of 1 minus x squared. And then we're going to use implicit differentiation. So we're going to take the derivative of both sides with respect to x. So the derivative of this side is, this is really 1 minus x squared to the 1/2. So this is 1/2 times 1 minus x squared to the negative 1/2 times the derivative of the inside function, which is negative 2x. Okay. So there's going to be some simplifying that happens there. Over here, what we have is, let's see, the derivative of the outside function, which is negative sine of the sine inverse of x, times, and this is the key part here, the derivative of the inside function, d dx of sine inverse. Okay. And we don't know what this is, and that's okay. We have enough now for us to solve. Okay. So let's do some simplifying now. Here we got negative sine of the sine inverse, and the sine of the sine inverse always cancel each other, so that just gives us negative x. Okay. Over here, this 2 and that 1/2 will cancel, and then I'm just going to clean this up a little bit. So this is negative 1 over the square root of 1 minus x squared times x. Okay. So this 1 minus x squared to the negative 1/2 is just the square root of the expression and then the reciprocal of that result. And then I still have d dx of sine inverse of x. And now we just solve for d dx, sine inverse of x. So d dx sine inverse of x is equal to, divide both sides by the negative x, and we get 1 over 1 minus x squared, the square root of the whole thing. So the derivative of the sine inverse is actually this purely algebraic expression. So this is kind of a crazy result, I admit. Okay, but if you think about it, when you use sine inverse, again, you're passing in an angle, and what you get out of there is a ratio. So you should get some ratio like this. And if you look at what's inside the square root here, there's some restrictions based on 1. X can only be as big as positive 1 and as small as negative 1. So it actually matches the range and domain of sine inverse that we talked about earlier. Well, I'm going to end this video here. I'm going to do one more derivative of another inverse function, and then you should be able to do the rest of them on your own. Thank you for watching, and have a great day.